Allison, thank you so much, and everybody, welcome today to this wonderful introduction to Neo4J. I am Andreas Colliger, your host for the next half hour or so. If you want to go ahead and tweet to me, of course, there's at @acolliger down there in the lower left, and you can always, of course, talk about Neo4J with hashtag Neo4J. And I'm hoping, of course, you'll be tweeting a lot after this lovely introduction. So what are we going to cover today? The path forward. Of course, first we're going to start with a simple introduction of well, why are we talking about this in the first place? Why do graphs matter? I'm sure that many of you have your own reasons for why you think that graphs could matter, that actually attracted you to showing to this webinar in the first place. And then, of course, we'll dive right into, what do we mean when we talk about a graph database? What is that thing? Some of you possibly already know. Hopefully, some of you have given Neo4j a try. And if not, after this webinar, you certainly should go off and give Neo4j a try. And for an idea of what people are actually doing with Neo4j, that's how we'll wrap this up today. We'll take a look at a few different use cases of real-world customers and what they're doing with Neo4j out there in the field. So the first question, of course, is really, again, why graphs? Why now are graphs suddenly relevant? And there's this data that's falling out of the sky, a bunch of data that's falling out of the sky. Heard of this term, I'm sure. There's lots of articles and lots of talk these days about big data, and big data really is just a term used to describe the trend that there's more and more data that's falling out of the sky and that all of us have to work with. And NoSQL is really a complement to big data. NoSQL is the technology that's been developed to respond to this increase in having data everywhere around that we've got to deal with, filling our warehouses and causing all kinds of new interesting challenges that we have in our applications. What's interesting about this big data is that it's large not only in volume, but it's also large in variety. That just because we've got a ton of stuff, the ton of stuff that we have that's falling out of the sky isn't just the same thing. We don't just have people. We've got people and, I don't know, it looks like animals and flags and all kinds of different stuff. And what's interesting to note, of course, is that within this variety of stuff, it's all related in various ways. If this is all part of our application, if our application is dealing with this huge variety of data that's in massive quantities, we're not suddenly forgetting about the fact that this stuff still has some relation to each other. It's not isolated bits of information. We know that the people possibly know each other, and that the people possibly own some of these sport items, and some of these they drive around in these cars to go to some of these locations. And so really, when we're looking at data and how it's all connected, what we're really describing is a graph. So all of this big data that's falling down in the sky, you can look at it individually, or you can look at how it's related to each step, to everything else. And these days, of course, everyone's actually talking about graphs a lot. Increasingly, people are talking about graphs. Facebook, of course, very famous, has its open graph. The social network is a social graph. Google this past summer, launched its knowledge graph because they've realized that what really helps people find things on the internet and how they can give more meaningful search results is by understanding a little bit about how things are actually related. And it's not just that this web page over here in this website is linking to some other website, but that there's some reason that they're linking. And if you understand what those reasons are, then you can actually give more informed rankings of how websites and web pages matter. Bing's getting into the act, of course. They're pulling in the Encyclopedia Britannica to try to improve their results. When they're doing that, of course, they're really also tapping into the knowledge graph that's contained within encyclopedias, because encyclopedias, while in their book-bound form or just a sequence of pages, when you throw it into a Wikipedia type example, suddenly it is also, again, incredibly valuable because of how all that data is connected and what else it leads you to. And then, of course, even Twitter is involved in this, because Twitter talks about the interest graph and how what people are talking about and how people are following each other implies a lot about what people are currently interested in. And marketers, of course, are turning into this because they want to figure out what people are interested in, so they know what you can sell these people. And then there's Neo4j, which is one of the NoSQL technologies that is a graph database that is from the ground up designed, purpose-built for handling graph data. So if you want to do any of these other things, if you want to be Facebook or Google or Bing or Twitter, you would start with Neo4j and then build an application up around that. And of course, graphs are everywhere. It's not just big websites that have graphs. We all have graphs. If we live in an everyday world, even before we get on the internet, the idea of talking about your own personal social network and working your network is very common within society. now that we have the internet, all of that sort of ambiguous social network, something becomes a lot more palpable. You can actually manipulate that social network. You can actually navigate through it. So you can, explore your own social network by looking at the people that you know and the people that they know, and kind of moving around and actually seeing the social network around you in a way that we only kind of conceived of it earlier. So this is my own personal social network from LinkedIn. This is the Colliger graph. And all of you have one of these. All of you, of course, if you're here online listening to me, you must also have, some sort of a social network account. And so you've got your own graph as well. And once you start thinking about the graphs that you have in your own life, you then also start to see that graphs truly are everywhere. So, what is it really about this graph? Like, how is that actually useful for being a graph database? So, when we say graph, what we really mean is it's a data structure. You're familiar with the common data structures. If you've been through CS 101 and you've had a data structures course, you've gone through all the simple things. You understand how linked lists work in trees. You know that an object actually, objects are connected to each other in an object graph. A graph is just a general purpose data structure for any information that is connected. So if you have data, and you have data that's not isolated, but it's related to other data, well, that having data that's related creates a graph. So of course, graphs have well understood patterns, and there's lots of academic papers and like research published around manipulating graphs and working with graphs, because it's not a new idea. They've been studied since good old Leonhard Euler studied his 7 bridges of Königsberg problem. This is when he was trying to solve mathematically a classic parlor argument about whether in Königsberg you could go around town crossing each of the bridges, the 7 bridges in town, by only crossing each bridge just once, whether or not that was possible. So graph theory actually started, with Leonhard sitting down and like figuring out, all right, can I mathematically prove whether or not this is something that's feasible? And that was back in the 1700s. For comparison, of course, the well-known relational model, which is the basis of all relational databases, rather than the 1700s, was back from the 70s. Certainly very well understood as well, and obviously, incredibly powerful and useful for all kinds of different applications. What's interesting, of course, is that graphs have been around a little bit longer, and it's not a new idea. Even back when relational databases were created back in the 70s, there were other database models, and among them there was an idea of a network model, is what they were calling it at the time. And that pretty much was a precursor to today's graph databases. And the thing is, it's back now, if we remember the slide about big data, because suddenly the problems that we're facing today are a little bit different than the problems that people were facing in the 70s. So it's not a new idea. It's just an idea that time has finally arrived. So a graph as a database. What does it mean to be a database? Of course, it means you can actually manipulate this data and run queries on it. So the graph database itself, the engine that drives it is optimized for performing operations on connections between records, which means it's super, super fast at doing queries when you're querying from record to record. So of course, as a database, it's properly transactional. In fact, with Neo4j, we have proper ACID transactions. It's not just a data store where you can save something and then get it back later, sort of a glorified file system. This is an actual database. It's transactional, so that when you save something, you can be guaranteed that either it was saved correctly, and then you can be confident in that, and you can later do queries on this. And there's a key sort of conceptual idea that's important when you're thinking about graph databases, and everyone has their own version of an aha moment around this. When they finally get it, when they finally understand what is the big deal about graphs at all. And this little quote here is one way to think about it, and I usually have variations on this. And for today, it's the idea that if you think about a relational database is really great at asking questions like, what's the average age of everyone who's in this webinar today? A relational database is fantastic for doing aggregate operations on sets, right? That's pretty much what it does. A graph database, though, is the kind of thing that you would ask for questions like, all right, I'm here in Baltimore right now. In the next week, I'm going to San Francisco, and I'm going to drive. I would ask a graph database, how would I get from Baltimore to San Francisco? The classic routing problem is a graph problem. And that shift in looking from, if I want to look at, alphabetizing the cities between here and San Francisco, maybe that would be a good thing for a relational database. But the route from here to there is something you ask a graph database. Now, that might be a little bit abstract, but it is that last bullet that is the key insight. If you can think of one thing as a result of this webinar, and maybe to mull over in your brain a little bit, and over dinner tonight at the dinner table, you can talk with other people about it and see if you can really get this idea. it is that last bullet that is the key insight that will help you understand like why graphs matter and what you can actually do that's fun with graphs. So we'll take one other look at that in a slightly different way. I'm sure that everybody here is, very familiar with the relational model, right? Everybody knows relational. If you've been doing any kind of computer applications and you've got data, people have been using relational databases for working with that data. So we'll take a look at a very common sort of pattern in relational database usage. So if we have here 3 tables, neatly stacked up as they tend to be in little squares within a relational database. And for argument's sake, we'll consider that the table on the left there is our foo table, and the table way on the right is the bar table. Now, a very, very common thing with relational schemas, no matter what application you have, this usually ends up coming out in some way, is that very often you have some of the bar records related to some of the foo records. And if they're related in a way that you want to say something about the relationship, so that it's not just a foreign key relationship, but you want to say, okay, well, I know that this particular bar is related to this foo, but I want to say something about that, like either you want to say, when that relationship was created, and maybe how strong that relationship is. You end up having what's called a join table in the middle. And classically, you have that join table named after the 2 tables that it joins. So the appropriate thing, of course, is if we have a foo and some bar, we have a foo bar in the middle that actually relates them. So the classic join query that you use this for looks something like this. You would first select something from the foo table, and of course in this query you want to find out what are the bars related to this particular foo. So to perform that, you just join across to the foo bar table, selecting those records, and then all the way across to the bar table. And if you have any problems in your routing so that you suddenly find yourself with jackhammers outside, I'm going to try to get moved to a slightly different room here and hopefully not lose my internet connection. And Allison, you can let me know if I've dropped out. But hopefully this will be a little bit quieter back here. So if we're doing this join and we have the foos and we have our bars and we've joined through them, this looks fairly normal, right? And we know we can do this, and we do this all the time for all kinds of different reasons. One of the interesting challenges about this is that that query runs just fine, but it's not necessarily the most performant because you're doing calculations to actually get from the foo to the foo bar to the bar. But it runs just fine, and this is sort of something that relational databases can handle without too much trouble. Now, instead of looking at it from a relational perspective, let's look at that same setup, but consider it as those connections are actually more than just foreign keys; those are actual relationships. And this is the graph view on things. So you take all the records that you had in the foo table and the bar table, and you just spread them out. Rather than having them in stacks, you just kind of spread them all out. And wherever you had connections, wherever there was a record in the foo bar table that represented a connection from the foos to the bars, rather than having that be a separate table, you have actual data structures that directly connect from the foos to the bars. So rather than being a calculation, here we can go ahead and grab our foo, and rather than calculating the foo bars, doing a join query to actually figure out what foo bars are related, it's actually just a data structure that has a pointer. So we're just following along the graph here. We're not actually doing any math. So we find the foo, then we go ahead and walk through the foo bars, which are just relationships now, and then we find the same bars. So really this is just a different sort of visual representation, but it also represents how, behind the scenes, mechanically this is different. In a relational database, you've got stacks of things you've got to do calculations on to actually find joins. In a graph database, all the joins that you're calculating are essentially pre-calculated because you have actual data structures, and you can just do a constant time query to actually follow paths along through the data. So that's kind of the DBA version of why you might consider graphs versus a relational model. So particularly with Neo4J, we're talking about a property graph. To actually be able to store data within the graph, you can't just have these data records and have them be empty. And we call our data records nodes. So those are the what would have been in the foos and the bars. And also we have relationships that are connecting the nodes. For the actual data, we don't have any schema in a graph, but we do have the ability to add particular keys and values to either the nodes or the relationships. So the same way that we had a join table and you could have any number of columns you wanted to, you can have any number of properties stored on the relationships. This is a very flexible model, of course, because there is no schema, there are no constraints. So here, by convention, I've had all of my nodes given names, and I've had all of my relationships been given the type of nodes. So this is a little social network that I've go ahead and created here. But this is the basic idea behind how you store data within a property graph. Also within Neo4j, Neo4j has indexes available so that for looking up that initial record, when you want to just grab the node named Andreas, you can just use an index for that and then query along after that. So it's a property graph. Neo4j. Okay, so that was sort of the generic look at what a graph is and what a graph database is. We're going to take a little bit closer look at Neo4j itself, as a graph database and what its features are. Of course, the initial way to do this, rather than listening to me drone on for a little while, is to just go ahead and Google Neo4j. If you were to do that, you would first find out, of course, that Neo4j is available out at neo4j.org. Neo4j.org is the home for the open source project that is Neo4j. And that's neat, knowing that it's an open source project. That's good to know. There's lots of people around the world actually developing this code. But there's also this company called neotechnology.com, a company that offers commercial licenses for Neo4j. So that if you're in a commercial business as well, and you're trying to make money, and you want to rely on this open source project that you're using, you want to have good support, and you're using it for your own business purposes, the way that Adobe is, and the way that Cisco is, and Deutsche Telekom, you could turn to neotechnology.com and buy commercial licenses for Neo4j. And of course, as an open source project, you can just go ahead and browse around through the source code out at GitHub, report issues there if you want to, and contribute code and patches. We have a very nice open source community that's very active in developing both contributions to the main core itself, but also contributing drivers and other frameworks and other applications that are built on Neo4j. And there's a very active sort of social component to all this. Of course, graphs themselves are very social, and the graph community is very social. So we've got meetups, spread around the world now. We're well over 4,000 people around the world that are actively getting together just about every month to talk about graphs and share their experiences. So if you don't have a meetup near you right now, and you should just go ahead and take a look at meetup.com to see if there is. But if you don't have one, go ahead and send me a note. I'd be happy to get you in touch with the people who run our meetups, and we'll see if we can get something set up near you. And of course, it's become so popular these days that we've even had just this past fall, just about a month ago, we had our very first graph conference around Neo4j in San Francisco, which was just a fantastic success. We had a really lovely, set of speakers who showed up, and just an incredible, actually, just a membership as well. Like the people who were in attendance had fantastic conversations and just really a great vibe the whole time. That was a really great success. So, if you yourself want to get started, though, start from the beginning, of course. You can go ahead and find documentation out about Neo4j in our own Neo4j manual, which is available online. The manual has great tutorials and it has a great reference section, so everything you really need to know about Neo4j is contained within that manual. There are also some books that are coming out sometime soon. There's one from Manning called Neo4j in Action. There's a good relationships book about Spring data Neo4j. So if you're a Java developer, that's definitely something you want to go ahead and check out because it's a fantastic way to do kind of the classic object-oriented, just annotate your POJOs and then have it saved to the database approach to doing modeling your data. That's pretty fantastic. But of course, you then want to go off and actually get Neo4j. You can get it from neo4j.org. Just do a direct download and just kick the tires. Just give it a try and see what you think about it. And if you like to, if you don't want to download it, feel free to go ahead and just sign up for an account over at Heroku. There is an add-on for Neo4j now that's available that is fantastic for just trying it out. There's no installs to do, nothing to download, and you can get the latest copy of the latest version of Neo4j available for your use almost immediately, and it's very convenient, great way to get up and started very quickly. And then once you've either tried it out in the cloud or downloaded it yourself, go out to Stack Overflow. That's the best place to actually get questions quickly answered about any kind of problems you might be having, or just look to see if somebody else has already had that same kind of problem. If you want to have discussions about what you're doing, join us in the Google groups, and of course show up at meetups, or continue to attend webinars like this. And we have much more detailed technical webinars covering all kinds of different topics past this light introduction. So again, Neo4j as a graph database. It is a graph, which means that it's a property graph. It has nodes, it has relationships, and there's properties on both of those things. And it's perfect for complex, highly connected data. So graph database, by database, of course, we mean it's a proper, reliable database with real ACID transactions, hugely scalable. Like you can put tons and tons and tons of data within this thing, and it runs a standalone server with a lovely REST API. And if you happen to be running on the JVM, you have the option as well of just embedding it within your application. So if you're developing some kind of a war that you're going to just deploy to Tomcat, you can actually have Neo4j running within your own application directly. That particularly happens to be fantastic and convenient for doing things like unit testing, so that your unit tests can very easily just spin up a database, do a bunch of work, and then destroy the database, which makes it really great for just doing rapid development. And of course, there's also available, whether it's embedded or whether you're running it as a server, you can have it as a high-performance cluster running high availability for the read scaling. So, how do you actually query this database? If it's a database, it must have a way of querying, right? It has a query language. Our query language for Neo4j is called Cypher. It is, of course, a graph query language. Cypher takes the approach of orienting everything that it does around pattern matching. So if you think about pattern matching from everybody's well-loved regular expressions, where you're just matching patterns of characters, right, to find particular characters that may or may not be present in some text. If you think about data in the same way, that's kind of what Cypher ends up doing. You just describe a pattern of the data. If you think back to the foo bar example, just what's the pattern from the foo, the little red records, onto the blue records. Describe that pattern, and then just ask Cypher to go off and find the results. It's declarative, of course, with different clauses, the way SQL is, and it can do the normal kind of aggregation and ordering, and it has all the usual CRUD operations as well, of course. This is a very quick, look at some examples of what Cypher actually looks like. With Cypher, you begin with a start clause. So in this very first example, if you look at the green text underneath the blue text, I'm doing the initial lookup of just finding that foo node. If you think back to the foo bar example, I'm just going to look up the foo from the people that I have. If I had modeled a little social network, I might have created an index for all the people. So I just go ahead and say, all right, I want a node from the people index where the name is Andreas, and I'm going to assign that to foo, and then just return foo. So there we go. I found foo, I found me, and then I've just returned it. To actually do the join that we described earlier, without having to do any calculations, but just following along the paths and then returning the results, here's what that would end up looking like. Start out the same way. I start with where foo is really the node from the people index with the name Andreas, and here's the pattern match part. So the pattern match, you can see like within parentheses, I'm describing the nodes, and then the dash dash arrow, of course, is the relationship. So the match is from some foo node, which I've defined as being a node from the people index named Andreas, follow outgoing relationships to any bars. So it doesn't matter what the relationships are, just go ahead and follow outgoing relationships and then return me all of the records that are attached there, and then return that collection of records. Simple as that. There we go. That's the join through the join table we described earlier in relational databases. That's what it looks like, with very, very little code here in Cypher. And of course, you can do things like creating data as well. You can update data and you can delete data. If you want to find more about Cypher, if you really are intrigued about this syntax, we have a fantastic webinar about this as well that you should really tune into. And of course, if you're really patient, you can just go off and read the Neo4j manual. The manual is pretty exhaustive about all aspects of the Cypher language, with really nice examples and even sort of a little live console that'll pop up that'll let you experiment with it there on the internet. Okay. So, Neo4j is a graph database. It's a graph, great, you can query it. Is it really production ready? This is always a question that comes up because it's an open source database. All right, great that Cisco happens to be using it, Adobe happens to be using it. How are they actually using it? People are using this in production, of course, because it is available as a clustering option, so you can have high availability. High availability is critical for any production scenario. So, of course, high availability ends up meaning you have master-slave replication. Typically, in any kind of scenario, you would end up deploying some kind of a load balancer, and then behind the load balancer, you would have a number of servers. And this is for read scaling, of course. So the way this ends up working is that one of the servers ends up being elected as the master, but any of the servers are possible to be elected as master. And in fact, the whole point of that is that you can very easily handle any kind of disasters that occur, right? So all of the clusters, all the members of the cluster could be within a single data center. You could have them spread out or around the planet if you want to, because the HA protocol that we have is very tolerant of high latency. In fact, Adobe is doing this. Adobe is deploying this in Asia and North America and Europe, one logical cluster that's spread across all those zones, and that's operating just fine, doing real-time performance for their whole application. And the whole point of the HA, though, really ends up being that you get redundancy, so you have improved uptime in addition to the read scaling. And the critical part there is that automatic failover. So if that server on the right side was our master, it's entirely possible that somebody sets it on fire or just at least unplugs it or turns it off accidentally, and then suddenly your master is gone. The cluster will continue to run. The other members of the cluster will quickly realize that the master is gone. Somebody else will be elected master, and then everything continues to run with no problems. The original master can rejoin. It'll figure out, oh, somebody else has become the master. Let me catch up. We handle all kinds of different scenarios very, very gracefully. This is fantastic for any kind of production scenario. I think actually you'd really enjoy it. So Neo4j is the high availability. So we'll take a look now at, it's great to know that Neo4j is a graph database. What are people really doing with it? We'll look at a few different real-world use cases. First, we'll look at Pancakes. And then we'll look at the ACL from hell. And we'll finish up by looking at the master of your domain. So first, Pancakes. Pancakes is, of course, one of these cleverly named little projects from our good friends over at Mozilla. Now, the people over at Mozilla have this Pancake project, which is an experimental cloud-based browser. Their thought here was that if you can figure out, essentially, if you can construct people's own view of the internet as they're doing browsing and save all that and preserve all that and follow their paths that they commonly go through, you can know a little bit more about what it is that they're discovering, and it'll actually help people sort of repeat the same patterns so that you can remember, oh yeah, what was that thing I was looking at last Tuesday, let's say. And generally when you're in a particular browser session, if you're doing searches, if you're looking for stuff, it's usually related to other stuff that you're already looking at. So if they have a memory of all that and they've followed the path of what you were doing all the time, they have a better idea of helping you out to find the stuff that you'd forgotten you were looking at previously. So that's their goal. Their goal is to basically curate the information that's available on the internet so that by repeatedly browsing along through this little Pancake browser, the browser ends up learning over time what kinds of things you're interested in looking at and helping you build a context around that. Of course, because it's out on the web, it'd be available on any device. That'd be very nice. Now, the why Neo4j part should seem pretty obvious. The internet itself is, of course, just a giant graph. That's certainly Google's view of it. That seems like a very natural view of it. So if you're just going to look at the internet and what you're trying to do is follow people's paths through the internet, why not store all that in a graph? It makes pretty good sense. And of course, the advantage there is that rather than trying to, and you could use any database you wanted to, really, but what's nice here is if this is how you were thinking about it, you don't have to do any kind of weird transform from your domain into the database. You don't have to have any kind of impedance mismatch whatsoever, of course, because how you're thinking about the data is exactly how you end up saving the data. This is a little bit of what we like to call the whiteboard friendliness of Neo4j, where very often, whatever you end up drawing out for your domain, there's nothing you have to do to change that when you're saving it to the database. Whatever you've drawn out, however you've described to a friend what it is you're trying to save, you just go ahead and save it the way that it looks. With all the circles and all the arrows as they are, obviously you've just drawn a graph. Just go ahead and save the graph directly. So that made it really easy for them to implement all their experimental features. It was very easy for them to change and update as they needed it to be. So this is what the metadata and the data itself sort of looks like. This is a sketch from them. It's really just them. So the whole part of the name Pancake, of course, is because they have a notion of stacks. They have a stack of different sessions of people, doing different browsing that they've sort of, separated out a little bit. And within each session, they keep track of where people have actually gone. And for each place that people have gone, what are the links where they could have gone? Where did they actually go? Did they go to someplace else that was not linked there, which means it's somehow an implied link that they knew something about. Maybe they used a bookmark to get to something else. That ends up still meaning possibly that all the stuff that people were doing within a particular session is somehow related. So they try to track all that and then take advantage of it later. One other interesting aspect about this whole project, this is a classic example of what we see fairly often in the NoSQL world, is that we're past the point where people just use one database for doing everything. Now, you could, of course, use everything within Neo4j, put everything within a graph database, and of course we would love that you would do that. But it's perfectly reasonable to actually, of course, combine Neo4j with other databases that are purpose-built for very, very narrow specific purposes. And so if in their choice here, they decided they still want to go ahead and use MySQL for the user data, they're going to use Redis for the metrics, but in a nice polyglot fashion, they have that all kind of combined into one application that is storing things in lots of different places. So that's Mozilla Pancake. It's available out on Bitbucket. It is another open source project. If you have any questions, feel free to get in touch with Olivier. He's a great guy, and he loves talking about his tech the way techies tend to really love talking about the stuff they're developing. Okay, now we'll take a look at the ACL from hell. And this is from our good friends over at Telenor, which is one of the top 10 telcos worldwide. If you're in Europe, you've certainly heard of Telenor, you're familiar with them. If you're not in Europe, possibly you haven't heard of them, but they're a pretty gigantic, incredible telco. So they had this particular problem where they were offering a service called Minbedrief, and I'm not sure really how that's pronounced, but that's how I'm going to pronounce it. And it was a self-service web solution for businesses, right? So this is really kind of a B2B thing that they were doing. And they had a problem with this particular service, though, and it had to do with simply user management, essentially. As they were running this web service, for every organization that was creating web applications that had users that needed to be managed, the way that they were managing the users and the access from that a particular user had permission to access a particular application wasn't really going to scale. In fact, they did a little calculation and realized that if they would continue with their current technology, they essentially wouldn't be able to guarantee that they'd be able to support the number of users that they hope to have, because just managing the users and the users' access control wasn't going to scale with the actual number of applications that they'd be able to have. So, an example of the access authentication that they were having problems with looks like this. This is sort of the model that they had for doing their access control list, where they had users, and the user, belongs to a customer that's a member of an account and that has a subscription, and all of that then has to get resolved for whether or not somebody basically has access to a particular application. So the business case that they were facing here is that while it looks like a very simple model, the way they had things set up, that it wasn't going to scale, and they realized that they would basically have to turn people away because they weren't able to just have this access control list scale with actual web applications that were being deployed. So they're going to lose a bunch of dollars, and that obviously meant that they had to find a solution. So with the current service, what was the limitation? The limitation was that they were doing this in a very traditional way. They had a stored procedure in a relational database that was calculating the access. And they would do this in a batch job, of course. They would just go ahead and batch up the results. They cache the results up to 1 day in advance. And depending on the size of the customer, it took them a couple minutes to actually do the calculation and then store that. And not only did it take a couple minutes, which isn't horrific because you're caching this up, and so maybe that's okay because actually servicing it isn't that bad, but it took a couple minutes to calculate, and the actual calculation, some 1,500 lines of SQL code. I don't know anybody who really wants to look at 1,500 lines of SQL code, let alone 1,500 lines of somebody else's SQL code, and figure out what it's doing and how it's doing it, so that if he needs to make any changes, if the tables actually change, if anything about the schema changes, or anything about the business requirements change, that you actually have to make some modifications. It sounds like a frightening idea, right? So it wasn't very maintainable, and the actual performance wasn't scalable. All the joins were becoming just a complete nightmare. The minutes were getting longer and longer. They had to do something different. That same ACL, doing that with Neo4j, ended up being, of course, way faster than the current solution. They went from having that run in minutes per customer to running in a second or two per customer. The logic went from 1,500 lines of SQL down to a handful of lines of just Cypher code. Way much easier to understand. If you think back to the Cypher example I had earlier, look, if you would think about the joins, how a join would have been described, the foo to the foo bar to the bar, much more complicated, many more lines of SQL code to actually express that than the simple pattern match with Cypher. And of course, the other advantage was that this is custom built and tailored for the actual service, so that it matched their domain. The data model and the way the database works were a very perfect match. So these are all huge advantages for Telenor and reasons why they ended up going with Neo4j. So master of your domain. This is a little surprising because this is our friends at Cisco. And when you first think of Cisco, of course, you don't think about master data management. You think about, routers and stuff. Like that seems like it'd be what they were using Neo4j for. And in fact, there's many projects within Cisco that they're using Neo4j for lots of different things. But the first thing that Cisco used Neo4j for within the organization was for master data management. That's how they first actually discovered Neo4j, and now it's being spread throughout the entire organization. So master data management within Cisco, if you're familiar with master data management, you already know, what it really means is that this is the modern term for talking about business entities and how they're related and business processes and like all the people that are involved in a business process and how things flow around your organization. They were doing this, of course, with a very lovely Oracle RAC solution. And the trouble was that the Oracle RAC solution was, well, slow in addition to being expensive. So it was costing a lot of dollars and it wasn't really fast, so that seemed like a bad thing. And what they wanted to do, of course, is have a lot more flexibility. One of the challenges with having something like master data management in a relational database is that it's like the worst case scenario for putting this within a system that's oriented around sets. With an organization, you don't have different sets as much as you have lots of individual records that are related in lots of different kinds of ways. So while everybody would like to have a very neat, hierarchical tree of their organization, we know that organizations are very complex and how people within them, work together is very complex, and it has to be very flexible. It changes all the time. Sometimes it changes on a day-to-day basis depending on how projects change, right? Who's working for whom on what thing. You want to be able to capture that so that actually you know what's going on within your business. So as a problem, it's actually perfectly suited for putting within a graph database. You have a much more flexible data model to actually represent exactly what you're trying to do in your application. And as it says here, one of the benefits is rather than having queries that run in minutes, the queries run in milliseconds. So suddenly you have all this highly connected data that you can actually do lots of interesting things with and have it running on a very solid, production-ready server like Neo4j. So this is why Cisco first discovered Neo4j. They were having problems essentially running joins. They had the classic join problem where their queries were just too slow. It was too cumbersome to actually doing that stuff. And they realized that they had a graph problem. They came looking for a graph solution and found Neo4j. Having found Neo4j, they realized, oh, wait a second, this is fantastic. We didn't even know this kind of thing existed. And now, group by group, more people within Cisco are using Neo4j for lots of different things. So that, of course, ends up really meaning the question ends up being, once you have your own sort of graph realization, once that idea I mentioned earlier about understanding why graphs matter, that whole shift from thinking in terms of sets in a relational world for in a graph world, thinking about taking advantage of how data is related, once you have one realization about how that can help you in your business or your application, you suddenly very quickly see that's everywhere. Whether that's trying to do recommendations, whether you're looking at geospatial, if you're doing catalogs of information, your brain itself is of course a graph. Huge applications in biotechnology and linguistics, all kinds of different applications, probably everywhere around the world. You can see graphs suddenly everywhere, and suddenly you realize you've got a tool that can take advantage of that. That would be Neo4j. So the question ends up being, now what will you build?